Hi viewers, this is Indumati, Assistant Professor, Department of Mechatronics Engineering. Let us get into the topic of math instructions in programmable logic controllers. Yes, if we need to code any programming operations means we of course need math instructions. In PLC also programming also, in PLC ladder programming also, of course we need math instructions of addition, subtraction, multiplication, division from BCD to BCD, square root, etc. So many of the math instructions are available. So let us see what are the math instruction available, how we are using it in the ladder logic diagram, and how it can be converted into the applications of different applications of these math instructions. Let us see, let us get into the topic now. So PLC math instructions allows us to perform different arithmetic functions on values stored in different memory words. For example, if we are assuming a counter to keep track of the number of parts manufactured, and we would like to display how many more must be produced in order to reach a certain quota, means this would require the data of the accumulated value of the counter to be subtracted from the quota required. In such case, accumulated value means the previous video we had seen about the counters, and the accumulated value of the counters means which is nothing but the accumulated value of the counter is the present counting value of the counter. That will be added or subtracted, or if we are comparing means greater than or less than, whatever the process requires, we can do it with in our PLC ladder logic diagrams using these math instructions. And what are the math instructions available in the PLC operation means addition, subtraction, multiplication, division. First we are going to see about the addition operation. In addition operation, basically source A and source B, two sources will be there, and destination. In source A, N7 is to 0 is the address, source A address. In that data is 25, and source B, N7 is 1 is the source B. In the data is 50, and both will be added. The final result will be stored in the N7 is to 2 destination address. This is the basic thing behind all arithmetic functions: addition, subtraction, multiplication, as well as in division. Everything, this is the basic concept behind it. The sources may vary different depending upon the counter values or timer values, or from different sources or different address values we can take it. But the destination address we can save it as any destination address. But the concept behind is same for all arithmetic functions: source A, source B, and destination. This will be for all addition, subtraction, multiplication, as well as in division also. And the next one is the counter program. How we are using the add instruction in the application things that we can see now. Here the problem is given. Actually above 350 the two counters are there. If it reaches above 350, both counters are added. When both counters, if it reaches above 350 means we should give the pilot light or any alarm light for the instructor. So for in such case we are doing this ladder logic program. So this is the counter program. This uses the ladder instructions. There is add instruction. This is the first counter. The name is C5 is to 0, and which is the preset value of 350. The preset value is the maximum upper limit of the counters. And next counter name is C5 is to 1. This is also up counter. This can able to count up to 350. This is also able to count 350. The source A is here. The addition operation performing here. This is our theme of the topic. So here the source A, C5 is to 0, comma, accumulated value. See here, first here, if limit switch 1 is closing, any parts is moving here means immediately limit switch 1 gets closed, and afterwards the counter will get increment by 1. If likewise the counter gets counting 1 by 1 by 1, you get increments, and finally the answer, if it is 100 means here the accumulated value is 100. The next counter is also starts counting 1 by 1 by 1. So here C5:1 starts counting, then limit switch 2 gets closed. So 2 limit switches are there, which is connected to 2 different counters. And here if it reaches 100 means, here if it reaches 150 means 100 plus 250 means 100 plus 250 will get added here, and the result is N7:1 will 350, which is stored in N7:1 destination address, which can be compared with the source A. Source A is compared with the source B. Source B is direct constant value, they are giving 350. So already these both are added, 100 plus 250, 350 is here. So 350 is equal to 350. Immediately what will happen means, if 350 will be equal to 350 means pilot light 1 will glow. Then next operation is reset operation will be performed for both the counters. Then again the 350, until it reaches 350, the counters will starts counting. This is the process behind the application, and the addition program also done through this counter program. Here one simple application that we are using the addition instruction as a PLC program. The next one is subtraction. As I told earlier, this is also source A, source B and destination. Source A is subtracted from the source B. This is the concept behind that. The same thing, N word 520 minus 322 will be subtracted, and immediately it will store in the N7:0. So next one is overfill alarm program. They are giving one sample application for this overfill alarm program. Here they are giving one fill solenoid, start stop buttons, and if the solenoid is filled means immediately the full valve will open, the filling will be happen. If it is greater than or equal to the source A, I012, and it is compared with 500, if I input 012 is compared with 500, if it is greater than or equal to 500 means then lot full light will glow. Then afterwards the lot full light will glow means then immediately the source is subtracted from 500 and it is compared with again the 5. So definitely the greater than or equal to will have the 5 means then alarm will be on. This is the process behind the subtraction program for one application overfill alarm program. Next one is multiplication. Of course here source A and source B will both get multiplied and the answer is stored in the destination address. And here the multiplication, source A 20 and source B C5:1 dot accumulated, that is source B, it is taken from the counter value, accumulated value of the counter 5:10. So both will be multiplied, the answer will be stored in N7:2 destination address. Here 3 source A's N7:1, source B N7:2, destination address N7:3. If N7 is both will be multiplied and if is 17503 means immediately pilot light will glow. This is for a simple application, and this is for over temperature control program. Here we are getting the input from I012 that will be multiplied by the 0.01 and this is stored in one destination N7:0. So automatically 400 into 0.01 we will get 4 as the answer here, and that will be added to the 400 plus 4, 404 will be added here, and the 404 that is 400 minus 4, 396 will be here. So for this 4 and that is this 400 minus 4 and 400 plus 4 will be compared here less than or greater than or equal to. If it exceeds or reaches the limit means immediately pilot light 1 and 2 will be glow, and according to the ranges the heater will be on or off. This is the over temperature control program application using multiplication, addition and subtraction. We can use all these things in a single program. This is a small example of the ladder logic program. And the next one is division instruction. Divide instruction divides the value in the source A by the value in the source B and stores the result in the destination and math register. So this is happening here. So here the divide source A C5:10.ACC counter accumulated value taken and that is divided by 2, that is saved in the N7:3 destination address. So here the sample program. So divide source A 120 divided by 4, which is 330 will be happening here. If 30 is equal to 30, the pilot light will glow. You can use it for any applications, not really a problem. And the next one is this one is a simple program which will convert degree centigrade to degree Fahrenheit program. The program of the following slide shows the converting degree to Fahrenheit, centigrade to Fahrenheit. So here the formula is F Fahrenheit equal to 9 by 5 into C plus 32. This is the simple formula we are going to apply here. So first one is 9. The input is multiplied by 9, then divided by 5, then finally added into 32. This will give you the display of converting the input. This DWS input is given to here, and this will convert into display of degree Fahrenheit. So this is how the degree centigrade will converted into degree Fahrenheit. And the next one is square root. In source A, if you are giving 25 means, of course the destination will get 5 as answer for square root. And this is square root instruction. 144, 12 will be the answer. So this word register has 144 as a data, and of course we will have the destination after executing this instruction. We will definitely have 12 as the answer. And next one is negation. Negation will convert the positive values into negative values. That's all. So here 101 means minus 101 will be there after executing the instruction. Minus 101 will be in the destination address. So clear instruction will clears you everything and will give you the 0 as the value. And 2 BCD means to convert the 2 BCD TOD output instruction is used to convert 16-bit integers into binary coded decimal values. So when the run condition is true, the TOD instruction converts the 16-bit integers stored at source A to BCD and places the answers in the destination. So these are all the math instructions which we have seen in the PLC. So using these PLCs, we can use these math instructions in the PLCs. We can apply it for different applications that we have seen about. Hope you will get a good idea on the topic of math instructions in PLC and how we can apply it in industries. Hope you can get the ideas. Keep learning and keep growing. Thanks for watching. If you have any queries, your comments in the